Today we will do second experiment, and in second experiment there are two parts. Okay, one part is measurement of fiber attenuation and another part is measurement of numerical aperture. Both of these are very important parameters regarding optical fiber. Fiber attenuation and numerical aperture. So in for attenuation, that is actually attenuation coefficients, you know that optical fiber ideally has zero attenuation, but still 1 or 2 dB loss per kilometer exists because of many reasons that you must have studied in theory, that absorption, scattering, etc., bending loss, radiative loss. And it depends and it varies from fiber to fiber. In glass fiber, it is very less, and even in single mode fiber, it is more. It is far less, and multi-mode fiber it is slightly higher in case of glass fiber, and in plastic fiber, it is loss is slightly higher. And you know that loss is dependent on wavelength. So you know that the spectral attenuation curve, that is alpha versus wavelength. Alpha versus wavelength. Alpha is dB per kilometer or dB per meter. So that is there, and many it has been obtained after a lot of studies for different wavelengths, different attenuation in different wavelength range, IR wavelength range, UV wavelength range, different kinds of loss are there, internal, external loss, absorption, etc. Now here in this experiment, we'll just see the loss alpha, and we'll calculate for different this how we'll calculate that we take different fiber length, okay? And for different fiber length we will give the input from one light source, okay? And we'll see the detected output and measure the voltage at the output side. So one CRO is used, that we'll pass actually one square wave. Simply what we can do, we can pass one square wave, okay, through the optical fiber, and the detected wavelength will be square wave. Okay. So that square wave, that magnitude of that square wave will measure for different fiber length. So at present we have three fiber. One fiber is have 0.5 meter, another fiber is of 10 meter, another is of 20 meter. So you make a table of one side and one column you mention fiber length, okay, fiber length, and another column you mention output voltage, in bracket peak to peak. So output means that is detected output voltage. Detected output voltage, bracket peak to peak, and for one column that will be for fiber length. So make three rows, one row for 0.5 meter, another row for 10 meter, another row for 20 meter. And you have to write the values, okay, for the detected output voltage from the CRO. So I will show each and everything. Okay. Now after getting these results, you have to plot one graph. Okay. So graph will be plotting. Plotting of the graph means plotting of these three data. Okay. One data is for 0.5 meter, one data is for 10 meter, another 20 meter. So you know that optical fiber voltage, that is signal strength, let us say it is called signal strength, it varies exponentially with fiber length. How it varies? So it has the is following relation that if V0 is the output voltage and V in is the input voltage, so V0 will be equal to V in into e to the power minus alpha L. So that alpha is actually the attenuation coefficient. So the relation between the output voltage and fiber length is actually exponential. Input voltage is constant. Input voltage magnitude is constant. It is a square wave or any voltage you can give. But if you measure the voltage at different length, okay, at different length of the fiber, the voltage changes exponentially or it is in decreasing fashion. So those 3 points that you will take will actually fall on a exponential graph, okay, parabolic exponential graph, exponential decreasing. But you have to take, you see the manual, I will show how the attenuation will be calculated. I have uploaded the manual, you can see there. Yes, this formula you see, that is cable attenuation is dB per meter. Okay? And formula is 10 log 10 base V1 by V2. Okay? And V1, V2 are the two voltages taken at for two different lengths. Let us say L1 and L2. And that should be taken from the graph. Okay? From the graph itself.
Sir, your screen is not being shared right now.
Okay. Now is it coming?
Yes, sir.
Okay. So formula for fiber attenuation is 10 log 10 V1 by V2 divided by delta L. Okay, so it is dB, unit is dB per meter for our experiment. And what is V1 and V2? V1 is the voltage, let us say at one length L1, and V2 as is another voltage, its length is L2. Okay, and V1 is larger than V2. Okay, so and delta L is the difference between that two length L1 minus L2. So, but that two voltages V1 and V2 will be arbitrary voltage and it will be taken from the graph drawn itself. Okay. So that graph actually will be drawn from those 3 points. Those 3 points will be coming in a exponential graph, decreasing graph. But you have to draw a straight line, approximate straight line, which will be close to all the points. But straight line should be drawn. Pure straight line that will you have to draw in such a way that it will be close to all the points. Okay, and from that straight line, take any two voltage, okay, any 2 points, and you note down the corresponding voltage and length. So, and apply this formula 10 log 10 V1 by V2 divided by delta L. Okay. So now I'll show the readings. So you see that here one circuit we have considered, that is circuit of astable multivibrator, okay, that generates square wave with certain frequency. Okay. And output is applied to an LED, a red light LED. Okay, so here you will get C square wave, and that is coming on, that is passing through the LED, and LED will emit light according to the square wave. So it will be on and off kind of thing. But since it is its frequency is higher, so you cannot see the blinking. So, but still the signal will propagate, and it will be propagated to fiber. Okay, and you see this is called the transmitter circuit. Now the detector circuit is given in the manual. Okay, here this is the detector. It is one kind of block diagram form, which is actually a kit where receiver circuit is in this position. Okay, so in the kit you see, now in coming to that experimental setup, here you see that we have constructed the 555 timer IC, okay, designed it, and the LED light is red light LED is coming out, and here we consider this fiber is a plastic fiber, a black one. This is a plastic fiber, and so now this is connected to this circuit. Okay, you see that it is detector. It is written. You see it is detector. Only this part we will consider detector. Detector outputs, detector 1, 2, this kind of things are there. We will consider this circuit. The second one we are applying to this port. Okay, this is fiber, another fiber end, and it is of just 1 minute. Okay. So this is, you know, that share the screen.
Sir, can you show the video mode, sir? When you're sharing the screen, it's lagging a little bit while you're showing the experiment.
Okay. So in present day sharing screen, it is not coming properly.
No, sir, it was coming, but last time when we did the experiment, no, sir. So video was more like less lag was there, sir, as compared to sharing of screen.
Okay, okay, okay. So I will not share. No issue. But for me, it was beneficial because it's coming in the larger screen. Okay, no issue. Okay, so now you see that this is the fiber cable Okay, and this is a 0.5 meter length. So we connect here on the top of the, we connect the fiber on the top of the LED. Okay, and you just place it in the detectors. So now it is coming to the detector. Now you see the detected output voltage coming to the sphere. Are you able to see?
Yes, sir.
Okay. उधर voltage थोड़ा adjust कीजिए. Now you note down the peak to peak voltage of this signal. ठीक है, छोटा ठीक है, ठीक है, वो बाद में छोटा हो जाएगा. 1 2 3 4 5 6 और ये 0.2 में है. ठीक है, तो थोड़ा नीचे कीजिए और अभी 6 यूनिट्स तक जा रहा है. 6 small units, 1 2 3 4 5 6 and in 0.2, so it is 1.2 volt. Okay, 1.2 volt is the detected output voltage for 0.5 fiber length, 0.5 meter fiber length. Okay, this is the whole setup. Okay, have you noted the reading?
Yes, sir.
Okay, now another fiber we take one side, yeah, no? This one. So it is of 10 meters. Directly you have applied the light on the fiber end, and one is connected to the detector. Okay, and you now see the output voltage. Now it is decreased. Okay, decreased a lot. It was exponential decrease. Because that was 0.5 meter and now it is 10 meters, so it is 20 times increased length. Okay, and you note down the voltage. ये थोड़ा बढ़ाइए इसको 0.1 में करिए. कितना हुआ अभी? 0.1 2 4 गया 0.2 0.2 और 0.1 divided by 1 मतलब 0.02 0.04 0.24. So note down the readings. हाँ? 1 कर दिए ना, 0.2 हो गया और एक स्मॉलेस्ट वाला है 0.02 और 0.04, 0.24 हो गया. कितना हुआ? For 10 meter, what is the output voltage?
Yes, sir. 0.24 volts.
Okay.
Sir, once can you explain how did you take that 0.24, sir? It's I understood 1.2, but how did you take 0.24?
So previous one 1.2 volt.
Yes, yes, I
0.5.
understood that, sir.
Previous one was for 0.5 meters. Because of exponential decrease in the length, e to the power minus alpha L. Now 20 meter कर दीजिए. ये तो ज्यादा कैसे हो गया? ठीक है ना? So now you see for this 20 meter length, it is 0.2 meter, a 0.2 volt. This 2 times length is increased in this case. In earlier case, length was 20 times increased. So in this case, it is doubled from previous one. That is earlier one was 10 meter, now it is 20 meter. So that much decrease is not there from the previous one. Okay, so these three readings I have given you. 0.5 meter gives you 1.2 volt. 10 meter gives you 0.24 volt, and 20 meter gives you how much volt?
Sir, 0.20 volts.
0.20, 0.2 volt. So now what you have to do, I am showing you now. ये देखो, यहाँ पे एक ग्राफ है. पहले का ये कौन सा है? ये है ना एटेन्यूएशन, ये है ना? ठीक है. ये नीचे वाला देखो, दिख रहा है नीचे वाला?
Sir,
ये
it's
ग्राफ.
not hardly visible, sir.
Okay.
Sir, can you take a photo of it? Like it would be more clear. We'll see it from here.
अभी दिख रहा है? एक पेन दीजिए, यहाँ से दीजिए, यहाँ से पता चल जाएगा. Is it clear?
Yes, sir, this is clear.
You see that there are 3 volt, 3 points, 1, 2, 3, 3 dots. This point, and this point. These 3 points will come like that, and you have to draw a straight line which will be close to all the points in approximated curve. Okay, straight line, and then take 2 points, this point and this points. Those 2 voltages are V1 and V2, and note corresponding length from this and this. Take the difference, that will give you the delta L, and apply the formula 10 log V1 by V2 by delta L, and what is the reading? So that will be the attenuation, okay, parameter, attenuation coefficient alpha. Okay, understood?
Yes, sir.
Okay.
Sir, for all the 3 readings means we'll get 2 alpha values, no, sir? I mean 3.
No. No, 1 alpha value.
So,
You are
sir,
not
for
understanding.
the extreme we should take.
See, I am again redrawing here. Let us say I am drawing here for your understanding. You have to draw the axis. This is length, and this is output voltage. Okay. Then from the reading you will get 3 points. These 3 points. Okay, and you have to draw one straight line like this. After drawing the straight line, take any 2 points from the graph. Let us say we take this point and this point. Okay. Then this will be these 2 points. So you will get some voltage here. Let us say this is V1. This is V1 and this voltage is V2 and corresponding length is L1 and L2. The difference delta L is what? Delta L is L2 minus L1. Okay, from the graph itself you will find it. And V1, V2 are two voltage. Then apply the formula alpha. 10 log V1 by V2 divided by delta L. Now it will come some value, okay, that you show you that you will get only after drawing the graph. Got it?
Yes, sir.
Okay. Now we'll move to the next experiment. That is fiber numerical aperture. Means in the same experiment, another part. So now you see numerical aperture. What do you mean by numerical aperture? Earlier we discussed it a lot. What is the formula for numerical aperture?
Sir, under root n1 square minus n2 square, where n1 is the refractive index of the core and n2 is of cladding.
And in terms of acceptance angle,
Sir, it
what
is
is the
n into sine theta max, where theta max is the acceptable angle and n is the refractive index of the medium from where the light is entering.
okay. So with this concept, we have some inbuilt circuit, inbuilt kit. Here you see is a transmitter kit. Okay, here transmitter circuit. Here this LED is connected to the at the collector. Okay, and some internal input is given. Okay, and it may be anything, sine wave, square wave, whatever it is. Okay, and at the output some signal will come, but we are bothered only in this diagram. Okay, what is this diagram tells that TTL input square wave will be applied to a digital driver circuit and it will go to the optical fibers. Okay, and from the optical fibers some light will be coming. So that light will be projected. That light will be projected on a paper. Graph paper hai lage. So that will make one circle. You have to measure the diameter of the circle. This concept is given in the manual. You have to study that. And we will vary the fiber distance from the fiber end to the plane where we will project the light. Okay, it will be clear when I show the experiment. Now you see this is the kit, okay, where the square wave is generated, okay, using transistor, and light is and fiber is connected to this knob. Okay, this is one LED actually, and light is going out and fiber is taken, and from output fiber end, the light is coming. Now we'll use one paper and note down the readings. And you scale, scale. तो ये देखो scale है. So what we do? Actually, this is this fiber, okay, and we'll generally we project the light coming out from the fiber onto the paper. And if I bring the fiber close to the paper, bring the fiber close to the paper, you see the spot size is decreasing. Okay? And if you move the fiber out from the page, then spot size is increasing. So depending on the distance from the page to the fiber end, the spot size will vary. So what we'll do in this experiment, we'll measure this different length. So what are the different lengths? Previous readings लाइए. कौन सा लेंथ लिया है? यहाँ पे कुछ टेबल नहीं था. अच्छा, यहाँ पे देखो टेबल है. First, you have to make this table 5 columns. Do you see? Can you see this table?
Yes, sir.
What is the first column?
Sir, D, sir, D is given. Small d in centimeters.
Yeah, D centimeters. Then MR, PM. Okay, these are the spot size diameter. Okay, mentioned in the manual. Spot size and diameter means one is vertical diameter, another is horizontal diameter, because you cannot draw the circle perfectly, okay, from the spot. So one average value should be taken. Average value of the diameter should be considered by taking the from the two diameter. One is vertical diameter, horizontal diameter, because it will be not a perfect circle. So like this, some people from some previous batch have done this way. We can see that this is vertical and this is horizontal. So small circle, and in this case, the distance between paper and fiber end is 0.5 centimeters. So you have to use this scale, okay? This scale, so it is 1 centimeter. This is 1 centimeter, and this is 0.5 centimeter. So keep the distance 0.5 centimeters. So I have kept the distance of 0.5 centimeter from the fiber end to the paper. Do you see this?
Yes, sir.
Okay. Now after keeping this distance fixed, you have to mark this one, this circle. Okay. तो ये एक सर्किल हो गया. Then let us say I want to keep it 1 meter, 0.5 0.8 centimeters. The 0.8 centimeter, that means this point. So you have to take another portion of the paper. Okay. Let us say this portion. So now 0.5, 0.8 distance, 0.8 centimeter distance is maintained, and make the circle from the spot. Do you see it?
Yes, sir.
Okay. Then go for another reading of 1.1 centimeters. 1.1 centimeter, it is this one. So that will give you this diameter. Then another 1.4, let us say 1.4. 1.4 centimeter, another spot. Then for another spot, let us say it is 2 centimeters, slightly higher. And for that case, let us draw the diameter like this. So from each of the spots, you see that I have drawn how many circles? 0.5. So this is for 0.5. This is for 1.1. This is for 1.4. This is for 0.8, 1.1, 1.4, and it is 2.0. All are centimeters. And measure this length. This is MR and this is EN. That is diameter, horizontal diameter and vertical diameter. And you have to calculate the radius. We will calculate the radius by this formula. R is equal to MR plus PN divided by 4. Because it is diameter, so radius is diameter by 2. Okay, radius is half of the diameters. And since we have taken 2 diameters, so it will be divided by 4. Okay. So this way we calculate the radius. No, this is not. This is radius of the spot, and for each of this spot, you have to calculate the radius according to this formula. This is for one distance. This is for another. So once you get all these radius values, then you have to apply this formula. That is numerical aperture is nothing but sine theta. Sine theta 0 max, where n is assumed to be 1. This sine theta 0 max, according to the trigonometry, sine theta is equal to height by hypotenuse. So this is given there. So d by d square r by d square plus r square whole square. Okay. So here, so that means it forms one triangle like this. Okay, this is what it is. That is theta 0 max, and this is your distance. Okay, from this is paper, and this is fiber end. This is D and this is R. There is the spot size. So this theta 0 max is what? This normal by this distance. This is R square plus D square. So sine theta 0 max is equal to R by root over R square plus D square. So you will get different values of numerical aperture for each and every distance. Distance is what? Distance between fiber end and the paper where you are projecting the light. So you will see the value, the fiber numerical, the numerical aperture is coming for the first case, it is 0.48, then 0.479, 0.455, 0.447 and 0.438. Okay, so you have to take an average value or numerical aperture, average from all these readings. So it is coming to be 0.45, 0.4598. And at the same time, you calculate the theta 0 max, that is acceptance angle. And this acceptance angle is coming within C, that is 27 degree near about, or within 30 degree from the axis. So this is the overall process of calculating the numerical aperture. So it is coming near about 0.45, or it should be slightly higher than that. Okay, because it's generally coming less than 0.5, 0.48 or something like that. So it is okay, no issue. Anyhow, it should be within 0.45 to 0.5. So you just note down the readings. Okay. So I'll give you just these values. So do you see the values?
Yes, sir.
You tell what are the values are there?
Sir, I'm starting, sir. So first one is 0.6, second one is 0.9, third one is 1.15, fourth one is 1.9, I guess, sir. And
1.4.
1.4, sir. Yes.
Yes.
1.4, 2.0. Yes.
And PM?
Sir, 0.5, 0.85, 1.10, 1.4, 1.9, sir.
Yes. And D distance?
Yes, sir. 0.5, 0.8, 1.1, 1.4, 2.0.
Yes. And all are in what unit? Centimeter. Yes. So accordingly, you make the table. Okay, these are the table you follow. I will not give you this reading for this. From the manual, you see the formula and make the corresponding table. And for each reading, you calculate the numerical aperture and theta zero max, and you take the average value of numerical aperture and theta zero max. Is it clear?
Yes.
Okay. So today's experiment is over. Anything you want to discuss?
Sir, how would be the exams or any idea, sir? Like before we used to have midsem exams, no, sir. So will we continue with the quizzes or like something like mid semester will be there?
Mid semester will not be there. Quizzes will be continued. Okay, because arranging the exam, it will be difficult, exam room. So we'll prefer for quiz, online quiz. There's no issue. Okay.
Yes, sir. Sir, and lab exam, how would be any idea, sir? Just for
Lab, all exam, NSEM exam will be offline.
yes, sir.
All NSEM exam.
Yes.
So try to score good in internal exam. Otherwise, you may not get that much good marks the pandemic time that you have got. All you got in around 90%. So should I repeat this experiment or it is okay?
It is okay, sir. We understood the thing, sir.
Okay. Anybody else have any doubt? Rishabh?